Hello and welcome to this session on lesson number 1, data transmission. This is part of the IGCSE Computer Science series of videos, and we are having a look at how we can use a Raspberry Pi preloaded with Kali Linux to learn about data transmission and also encryption. Now, we are going to be using the Raspberry Pi preloaded with Kali for topic 2, data transmission, topic 5, cybersecurity, and also topic number 9, databases. And this is going to be your first lesson on how to actually use this device in your pairs. And if you are watching this video and you are not one of my students, or you are a teacher who wants to be able to use these resources, just drop me a message underneath this video. But otherwise, let's get started with today's lesson. So the slides which I'm presenting, it's likely that some of these might change as we kind of go through this session on data transmission with the Raspberry Pi. And when I'm talking about the Pi, right, this is not something which we are talking about here. We are actually talking about a credit card sized computer that we are using for this session. And I want you to try to remember that this is not as powerful as probably your laptops or your mobile phones. It does have 8 gigabytes of RAM, but the processor isn't the same as a processor inside a computer. So do bear with it sometimes, but pretty much everything we're doing is going to be on a command line, so it should be fast enough for what we need. Now, you will be able to see your objectives for today's session. Hopefully you've managed to log on to the Raspberry Pi using the credentials. The operating system that we are using is Kali Linux, and this is an operating system that people use in industry for penetration testing, and this is what we're going to be using it for, both for data transmission and also cybersecurity a little bit later. This is a Linux distribution, so it's different to Windows, different to Mac. This is a type of operating system, as I said, which is commonly used in penetration testing, or we can say cybersecurity. Now, these are the different skills which you are going to be developing in this video here, and we are going to talk a little bit about Kali Linux to begin with. So as I said, it's used in pen testing, it's used in cyber. We can use this operating system as, let's say, an ethical hacker, right? So we can use this to assess systems weaknesses. We can look at routers, we can look at network switches, we can look at access points, we can look at firewalls, we can look at mobile phones, we can look at computers, we can look at any device that has been assigned an IP address. And what we can do with this operating system is look to see if there are any potential weaknesses that would expose them to hackers on the internet. That is pretty much everything which we can use it for. There are so many things which you are going to learn today, so we're going to get started with the Pi. So hopefully, if you are logged onto your Pi, you are going to be the root user to begin with anyway. But later on in the session, you're actually going to be logging in with a different account where you're not root. So I am going to show you a couple of different commands. So let me resize my terminal window. And just in case you're wondering what I have open, this black button up here will open up a terminal window. This is the command prompt. Now, with our terminal window open, if I do want to use the applications inside this operating system, I could go to the start menu in the top left. And this is going to look similar to kind of like Windows and Mac, right? We could click on these different applications, but actually you're just going to be controlling the computer through code. And for everything which you've kind of learned in programming so far, right, you will know that when we are using code to like write a program, or in this case to control a device, the commands do have to be used correctly, or what you're doing will not work. Now, what I've done is I've just zoomed in on my terminal window, and you're probably going to want to do the same thing when you're working on these Pis, just so it's a bit more visible for you. So to do that, you press Control, Shift and plus on your keyboard, and that will allow you to zoom in. If you want to zoom out, you press Control and minus, and that will allow you to zoom out. Now, on Google Slides, you're going to be able to see that I'm logged in as Kali here. That is not the case when I'm logged onto my Pi right now. If you are a standard user that doesn't have any permissions, that means you're not the administrator, you would need to use the command sudo su to become root. And this is going to be something which you're going to want to do later when you do log onto the device. where you don't have any privileges and you want to become, let's say, a root user or an administrator. Now I'm going to skip over these Windows slides. These are going to be deleted by the time you start the session, and we are going to begin with how to update and upgrade your operating system. Now these devices are not managed by our IT department. You are going to want to make sure that you're using the most up-to-date version of Kali Linux or any Linux operating system when you log on. So you need to firstly learn how to update it. So if you're the root user, you type in apt and update. And what this is going to do is check to see if there are any applications that need updating or if there are any patches that need to be applied to our operating system. Once you have done this, you are going to run an upgrade command. We can see that we're 97% done. I'm going to go back to the presentation and just move it up a little bit so we can see this. So there are a couple of commands. We've got upgrade and then also these upgrade commands, which I'm going to come to in a moment. Okay, so what we can see is that 28 packages need to be upgraded, and when you're using this operating system, you're going to want everything to be up to date, so you have all resources or up-to-date resources available. So to do an upgrade, we can do apt and then upgrade, and each time you log onto the system, you're going to want to make sure it's upgraded, and I can be teaching you some of the theory stuff that we need to go through whilst this is upgrading. Now, if this upgrade fails for any reason, we can use the command apt and dist and upgrade. And if this fails or some of the installations don't complete, we can use apt and full upgrade. So you use it in the order of apt upgrade. If anything fails, use dist upgrade. If dist upgrade fails, we can use full upgrade. And I'm going to do a full upgrade on this system now and press enter. And this is going to update all of the packages which are installed on this operating system. It says, do you want to continue? The answer is yes. And we will leave this updating and move to the theory aspect of the lesson. Okay, so welcome back. So you'll be able to see that our Raspberry Pi is up to date, or Kali Linux is up to date, okay? And we should be good to move on with this session. Now, what we're going to be doing to begin with is looking at how we can find our IP address and also identify what our MAC address is. Now, first of all, those two terms are particularly important for this course. So IP address, IP stands for Internet Protocol. MAC address stands for Media Access Control. Now, what is your IP address and how do you find it? So if we type in ifconfig, we will be able to scroll up, and we are connected through an Ethernet cable. So that's an Ethernet cable plugged into the back of your device, and we're able to identify this number here. Now, this is going to look a little bit different to you because I'm using a different class of network as I am recording this at home, and we're able to identify that it's been assigned this number. Now, all of your Raspberry Pis or all of your operating systems are going to have different IP addresses, and this is what allows us to have an open connection to the internet. Now, once we've been assigned an IP address, we're going to have, as I said, a connection to the internet. But in order for that to work, we have to be able to use the MAC address of the device. And as I said, MAC stands for Media Access Control, and that is the physical address of the device. So the Ethernet port on my Raspberry Pi has got this MAC address. This is the physical address, and you can see that it is in hexadecimal notation. In order for a device to have an internet connection, we have to be able to look at what the MAC address is, and then we're going to assign this IP address to the device, so we have that open gateway to the internet. Now here we're going to be able to see that the interface is Ethernet 0 because we are using a cable. This here is going to be our local interface. We're not going to learn anything about this today, but also down here we're going to have our wireless interface, and this is what all of your laptops are going to be using at school because you are connecting to a wireless network. Notice down here we have got the MAC address of the wireless card on our Raspberry Pi, but there's no IP address because we are connected through an Ethernet connection. And this is how we get a connection to the internet, and it's going to be assigned an IP address by a network switch or an access point or a router, depending on what type of network you're in. And this is obviously how we connect to the internet. Now, what I'm going to do here is move on to the next part of this session. You're going to study some of the theory aspects of this course with me. But to begin with now, we are going to have a look at the traceroute command and also the ping command. Now, Traceroute comes pre-installed on your Raspberry Pis or your operating systems here. If you did want to check that it's installed, we could do apt install and traceroute, but as I said, it's already installed, right? And we're going to be able to see that nothing has been upgraded and nothing has been newly installed. Now, these two things are particularly important for us because we want to be able to see if we can access different websites within inside our network. We want to be able to see if we can ping different network devices. Now, let's have a look at that ping command to begin with. So if you are trying to access, let's say, an application or a website within a network, let's say a school network, if it has been blocked, the ping command is going to allow you to see if it has been blocked locally on the network, or maybe it's been blocked by your internet service provider or even on your countrywide firewall. Now, I want to see if I can access facebook.com. So I'm going to send a ping request to Facebook. So this is sending request to Facebook. To stop this ping, I can press on Control-C. And what we're going to be able to see here is 8 packets of data were transmitted to Facebook's server. 8 of them were received, and there is 0% packet loss. So that's quite a good thing, right? No packet loss, no packets got lost on the way there, and we can see the time it took for this request to be received by Facebook's server. Now, if you were seeing 0 received, that means that potentially the web server that you're trying to access is down, or maybe that website or application has been blocked on your local network by your ISP, or maybe on a countrywide firewall. And what you'll be able to see is at school, if you ping TikTok and look for their official URL, right, you will be able to identify if it's accessible within a network or if it has been blocked. Now, if it has been blocked, we will be able to find out where it has been blocked by using the traceroute command. If I type in traceroute like this, and if I type in google.com, this is going to be able to show us, and I'm going to expand my terminal window here, this is going to be able to show us all of the servers that it is bouncing through in the world in order to load Facebook or google.com, right? So first of all, this address up here is going to be our router IP address, which finishes in .1. We're then going through our ISP, so my ISP is AIS, and then we're bouncing through all of these other web servers in the world in order to be able to load google.com on our Raspberry Pi, and it took a total of 16 requests. Now, if I was to do this with, let's say, my company, steamlabs.co.th, it's going to be a little bit slower than Google's, and it's going to show us all of the IP addresses it is jumping through in the world in order to be able to load Steamlabs, let's say, inside a web browser on this device. Now, as I said, this works with both IP addresses and also URLs. So what I'm going to do is go into a web browser here. I'm going to go into an incognito window so you can't see my history. And then what we are going to do is type in who.is IP. And this is going to take us to a URL that allows us to find the IP address which is behind a website. So when you type in a URL like whois.com, google.com, steamlabs.co.th, right, there is an IP address which is behind that URL. The reason why there is an IP address behind that URL, the URL is like ASCII, right? So it's a friendly language which we can type in to find an IP address, or website address, apologies. But actually behind that, when we are loading a website, it's going to be using a static IP, which is a fixed IP address. So if I type in steamlabs.co.th and press on search, we're going to be able to find that fixed or static IP that is behind this URL. So if I do copy link or just copy here and head back over to that terminal window, just like when we use traceroute on the URL for Steam Labs, we can also ping that as well and also type in traceroute. And as I said, this allows us to identify the paths that it is going through in order to load this on a domain, which we can see here. And it is showing us if it is blocked anywhere along the way. And can we ping this address? We are going to do ping and then paste. And it allows us to see if we can access this web server. Now, hopefully the concepts of ping and also traceroute are clear. Do obviously ask me questions in the session if you're not sure what we're using these for. But as I said, ping allows us to see if we can access something, if it's been blocked. Traceroute is going to allow us to look at all of the different web services jumping through in order to load something in a browser or in order to load an application. Now, the next thing that we are going to be doing here is typing in the command clear. So we have a new terminal window to work with, so nice and fresh. And we're going to be using a tool which is called netdiscover. Now, netdiscover is going to allow us to identify all of the different IP addresses that are on our network. And we can see that I'm able to identify fiber home telecommunications, so this is going to be our router. We can see the MAC address for that router as well. We can also see my Mac, which is here. We've got my Philips light bulbs, which is all of the lighting in my office, a Western Digital hard disk, and also this device as well. Not sure what this device is. This is most likely going to be a Raspberry Pi inside our network. So netdiscover allows us to identify all of the different IP addresses that are on my router or my home router, and this is going to allow you to see all of the different IP addresses which are running inside our classroom. Now, we can use this to find out the IP addresses and see if we can ping the different IP addresses within inside our network. So I could type in ping 192.168.1.109, and it's going to allow me to see if I can ping the device or access the device from my Raspberry Pi. And we can see that the ping address or the ping is successful and 4 packets of data were transmitted and also received. Now, what we want to do to begin with today is look at a command which is called nmap. So we want to find out what different services are running on this IP address and also what ports are open. So we're going to type in nmap 192.168.1.109. And this is going to do a port scan on the device, and it should return the different services or applications which are running on this IP address. Now, this is going to take a moment to return the results. And what we're going to be able to see is that there is one port open on this device. Now, I'm going to pick a different IP address, and we're going to talk a little bit more about what nmap is or does and how we can use it in today's session. As mentioned, we are going to have a look at what we can use nmap for in a bit more detail. Now, over here in my terminal window, I have written in the command clear, so there is nothing in here. So if you type in clear like this, it will make sure we've got a fresh terminal window to work with. Now, what we want to do is understand a little bit more about nmap. So this is all about data transmission, so how information is traveling across a network. If we type in netdiscover again, it's going to show us all of the different IP addresses that are within our local area network. And if I hit Command C or Control C to end this, what we can do is an nmap scan on our router IP address. And you can do this on pretty much any IP address which you discover. I'm going to be choosing my router IP, which is 192.168.1.1. For you, you can choose any IP address that you're able to pick up on netdiscover. And what we're going to do here is identify what different ports are open. Now, ports are particularly important. There are over 65,000 ports on an IP address. They tell us the different services that are running. And if we have got information which is traveling through a web browser, so port HTTP, which is port 80, and HTTPS, which is port 443, that will tell us that there is web traffic passing through this device here. So nmap will list all of the different ports which are open. Now we are going to be using a tool today which is called wireshark to analyze network traffic. So going to the star icon in the top left, if you type in WIRE, we're looking for the one with the shark fin which looks like this, and it's going to open up this tool here. Now you need to make sure that you've got Ethernet 0 selected here, and then what we're going to do is press on the shark icon to start capturing packets. And what you'll be able to see here is lots of IP addresses and information which is being passed through our router here. So this is all of the traffic that is being passed across our network and obviously out to the internet as well. I'm going to select on the stop icon for now, and we're going to conduct a couple of different types of scan here using nmap, and we're going to have a look at those results inside this graphical window which is wireshark here. Now I'm going to pick any IP address, so I'm going to choose 109. Again, you're going to be able to pick any IP address which you can find inside the network. We are going to type in the nmap command, and any IP address that you have chosen here, remember it's going to be different to the one which I am using here. And we're going to conduct something which is called an ARP scan. And this is going to send a message across the network, and it is going to say who is using this IP address, return this information to the Raspberry Pi. Now, in order to filter inside Wireshark, you're going to need to type in the command IP address, and you're going to need to type in == and then the IP address here. So hopefully that's nice and clear for you. You can see that I'm using IP address 109 here, and we're doing something which is called an ARP scan. So we're going to type in space, and then we're going to do pipe. So in order to do pipe, you hold down shift, and then the pipe symbol is above the enter key. And then we're going to type in space and ARP. Now this is the type of scan which we are doing. We're specifying a particular protocol. I am going to press on the start icon up here and press on continue without saving and press enter on my keyboard in the terminal window. Now I'm going to be telling you what you are looking for. We are saying from our Raspberry Pi who is using this IP address. We want this information to be returned to our Raspberry Pi. So we're saying who is using IP address 109. We want this to be told to our Raspberry Pi IP address, which is going to be IP address 107 here. Now we can say who is IP address 109, and we're saying return this information to IP address 107. And this is that line that we are looking for. So we can see here, we've sent a protocol or a message out saying who's using this IP address, send this information back to IP address 107. And what this has done is it has returned the MAC address to this Raspberry Pi. And we call this an ARP scan. Now, as I said, if we want to filter out a particular type of protocol, we need to do the pipe symbol and then the type of protocol that we are focusing on. If I get rid of this here and just do a scan for everything which is traveling across this IP address, which is going to be my Mac operating system, we're going to be able to see all of the traffic that is passing across this network here. We can still see it's on the ARP protocol right now, so we're going to need to press on enter again, and we should be able to see other network traffic moving back across. Now, for the last part of this session using Kali Linux for data transmission, topic number 2, we are going to be having a look at how we can encrypt and decrypt data using Kali Linux. Now, anything which is using HTTPS, so that's going to be a URL, right, which is using encryption, we're not actually going to be able to read any of that data if we do intercept it, or we intercept any data through Wireshark. But what we are going to have a look at how encryption actually works and have a look at how we can use this on our device today. Now what we are going to be doing is copying this command from Google Slides. You're probably going to need to type in this command onto Kali unless you have logged into your account using your Gmail address, and we're going to paste this onto our command line here. But you can see for me it isn't working, so that's fine. So what I am going to do is I am just going to type in git and then clone and then the URL. So https github.com/node/socket/cryptr, and let's spell it correctly, and then .git. Now git clone is allowing us to use the GitHub repository to install a tool on our device. We're taking it from the URL github.com, and the package that we are installing today is called cryptr. So I'm going to press on enter. Let's see if there's any mistakes in my command. That looks pretty good to me. To finish setting up cryptr, we are going to need to type this command at the bottom of Google Slides on our command line. Make sure that you are in your root directory. You can ignore these commands which I was using above. What we are going to do here is we are going to type in ln-s, and again you need to make sure that this is 100% correct. We are going to type in speech mark and then $, and then we are typing in pwd in uppercase. We are typing in speech mark, and then we're going to do cryptr, so CRYPTR /cryptr again, and then finishing with crypt. So we have typed in this command. If we do a quick visual check, so we're typing in ln-s, we have got speech marks, $pwd, speech marks /cryptr/cryptr.bash, then we've got space, and then we've got user/local/bin, and then /crypt. I'm going to press on enter now. And now that we have typed that in, we are fully set up and we should be good to go with cryptr. Now we're going to have to log into the cryptr directory. So if we type in ls here, we're going to be able to see all of the different applications or folders which we have inside our root directory. To log into cryptr, we're going to type in cd and then cryptr. Once we have done this, we're going to type in ls. And what we're going to be able to see here is all of the different packages which are inside this cryptr directory. For the next part, do have a read of the instructions which are on Google Slides. As long as you're in the cryptr directory, we should be good to go. Now, a couple of different things which I'm going to be teaching you here. We have got the keyword plain text, and we've also got the keyword ciphertext. It's going to talk you through the difference between plain text and ciphertext here. You're going to need to make sure that you have also updated this within your notes as well. Now, what we want to do is we want to take a file which is in plain text, we want to encrypt it, and then that is going to become ciphertext. The first thing which we're going to need to do is we're going to need to create a folder. So to create a folder, or let's say a file with data in, apologies there, we're going to type in nano, and we're going to say robs file.txt. So .txt is the format of the file. We're going to type in, hi, my name is Rob, can you read this message? To exit this folder, you press on Control X on your keyboard, Y to save, and then enter. And then the next thing we're going to want to do is we're going to want to see, can we read the data from this file? Now, in order to read the data, you're going to type in the command cat, the name of your file, .txt, and then this is going to print out all of the data which exists in that file. So this is what we use the cat command for. Now, what we want to do is we want to see, can we encrypt this file, so if somebody intercepts it, somebody hacks us through the internet, right, are they going to be able to read that data in a plain text form? So we're going to try to encrypt it. So we're going to use that command which you can see on the left-hand side inside Google Slides. So we're going to type in the command crypt, and we're going to say encrypt. Make sure you spell everything correctly. And then we're going to type in the name of a file, which is going to be robsfile.txt, or whatever you called your file. Once we press on enter, we're going to be asked to enter a password. I'm going to enter a nice strong password here of 1234. Remember, we can't see the password we're typing in on a terminal window. We're going to enter that password again. And now our data should be encrypted. Now, what we want to do is we want to see is the file, Rob's file, has this been encrypted? So to find that out, we're going to type in ls here to show all of our files. And this time we've got Rob's file txt, but also Rob's file txt.aes. And this is our encrypted file. Now, if we try to read the contents of this file, we're going to type in cat Rob's file txt.aes. And we're going to see that we've got like a gobbledygook language here. So if we wanted to securely send a file to somebody, if we were worrying if somebody might intercept that file and read that secret message which we have in there, we can use this form of AES encryption using cryptr. And this means that if anybody intercepts a file, they're going to need to have the password if they want to see what the message or what the data is inside this file inside plain text. Now, this is pretty much all you're going to be using Kali Linux for in lesson number 1, topic 2 for data transmission. Hopefully you have a basic understanding of how to use some of these different tools, how to use encryption, how to use nmap, how to use netdiscover, what traceroute and ping do, and all of the other things that we have covered. I do hope this lesson has been enjoyable for you, and I am looking forward to using Kali Linux again with you in future lessons. Do remember that if you are not one of my students and you want access to these lesson resources, do drop me a message underneath this video.